Hello everyone, welcome to Meritnation YouTube live session. This is our first session of Waves. Hi Dinesh, Braj Kishore, Meghna. I hope you guys are doing well. So soon we'll start our session. So here you can see on your screen, basically in this class we are going to discuss few questions based on waves. Okay, and we'll talk about the direction of motion of waves, direction of particle, direction, or you can say we'll talk about the open organ pipe and closed organ pipe. So let's start now. So you can see on your screen first question. A transverse sinusoidal wave moves along a string in the positive x direction at a speed of 10 centimeter per second. The wavelength of the wave is zero point 0.5 meter and its amplitude is 10 centimeter. At a particular time t, the snapshot of the wave is shown in figure. You can see here. Okay. Then the velocity of the point P when its displacement is 5 centimeter is what? Okay. So we have to find out the velocity of this P point. So let's start now. So first of all, let me give you just idea about the direction of motion of wave and direction of particle. Let's see here. So here we can discuss. First, you can see this is the equation of wave. Y is equals to A sine omega t minus kx plus phi. Okay. So if we'll talk about the direction of motion of wave, suppose if we take here a wave, suppose this is the wave. Okay, this is the wave, and see, and suppose this wave is traveling in this direction. You can say traveling towards positive x-axis. See, this one is traveling towards positive x-axis with a speed v. Okay, this v is what? Velocity of wave. Velocity of wave, I can say. Now, but how can we find out the velocity of wave? First of all, you can see this is x now here. You can see here the coefficient. Here you can see k into x. So here x means what? X means wave is traveling on x-axis. Wave is traveling on x axis x-axis, but we don't know whether the wave is traveling towards positive x-axis and negative x-axis. So how can we check whether the wave is traveling in positive x-axis or negative x-axis? So for that we can do one thing here. First we need to check here the coefficient of t and coefficient of we can say x. So first of all, basically we need to check sine. We need to check sine of x and t. Okay, if sine of x and t is same. Okay, if sine of x and t is same, so in that case direction of motion of wave is what? Towards negative direction. Towards direction negative direction, same sign. If if the sign of x and t is same, then in that case direction of motion of wave will be what? Towards negative x direction. Suppose if the sign of x is negative, sign of t is also negative, then direction of motion of wave will be towards negative x axis. If sign of x is positive and for t also positive, again in that case direction will be towards negative x-axis. But what about the different sign? Suppose if direction of if you can say the sign of x and t is different, then in that case direction of motion of wave will be towards positive x-axis. For different sign direction of motion will be what? Towards positive x axis, or here you can say negative direction. Okay, or I can say here towards negative x axis. Okay, whenever sign is same. See, here I can say negative x axis. So if sign of x is plus and sign of t is negative, So in that case, direction of motion of wave will be what? Towards positive x-axis. If sign of x is negative and sign of t is what? Positive. So in that case, also direction of motion of wave will be towards positive x-axis. Okay. So this is the way which we can use to find out the direction in which basically our given wave is traveling. Okay. So one more thing, we can also find out the magnitude of velocity of the wave. How? Let me give you the formula. So you can see velocity of wave. Velocity of wave. So simply we can take here first mode, because we are talking about the magnitude. So we can take here mode, and that is basically the ratio of coefficient of t. Coefficient of t divided by coefficient of x. Okay, this ratio will give you the velocity of wave. That will only give you the magnitude of velocity of wave. Magnitude of velocity of wave. Okay, so this formula we can use to get the magnitude of velocity of wave. Okay, and what about this way? Okay, what about this method? We can use this method, or you can say this shortcut, to get the direction of motion of wave. Okay, this is for direction. Okay, this is for direction. Right now you can see, suppose if this is the equation of wave, suppose y is equal to a sine omega t plus kx plus phi. Okay, so suppose we need to find out the direction of motion of wave, as well as the magnitude of velocity of wave. So let's see here. So first of all, if we talk about the direction, then in that case we need to check the sign of t and k. See here, sign of t is what? Positive. Sign of x is also positive here. Okay, so both are positive. So you know very well, whenever both t and x having same sign, in that case direction is what? In that case direction is negative. It means towards negative x-axis. Towards negative, towards negative x-axis. Negative x axis. So case, now next one, now let's talk about the magnitude. So see here, this is the formula, coefficient of t divided by coefficient of x. So we can use this formula. So v is equal to, see here, coefficient, if this is the equation of motion, this is the equation of wave na? So here coefficient of t is what? Omega. Coefficient of x is what? K. So this is omega by k. It means, this implies here v is equal to omega by k. It means velocity of this wave is omega by k, and direction, and we can say that direction of motion of this wave is what? Towards negative x-axis. Because you can see here x is given, it means wave is traveling in the x direction, but we need to check whether the wave is traveling in towards negative x-axis or positive x-axis. And these are the two ways which we can use to get the direction. See, if the sign of x and t is same, it means both are traveling in, it mean in that case wave is traveling in negative x-axis. If sign is different, so wave is traveling towards positive x-axis. This is all about the direction of motion of wave and the velocity of wave. Now let's talk about the velocity of particle. How can we find out the direction of velocity of particle as well as the magnitude of particle? Let's see here. So let me show you here. Just a second. Okay, so if we'll talk about the particles, suppose let us take here a particle first. Suppose this is our wave. Okay, and let's suppose that this wave is traveling in this direction. Let us suppose that. And suppose this is the particle P. Okay, and we have to find out the direction, we have to find out the direction of motion of this particle. Okay, so suppose Vp is velocity of particle. Velocity of particle. Okay, so now you can see here In this case, first of all, equation of this wave is what? Y is equals to a sine omega t minus kx plus phi. Let us suppose that this is the equation. Okay, this is the equation. Now we can do here one thing. If this is the if this p point is what? Velocity of particle. Okay, vp is what? Velocity of particle. We need to find out a direction. So students, let me give you the shortcut first. If wave is traveling in this direction, if wave is traveling in this direction, so after t time, this will be the position of the wave. See, after t time, this will be the position of the wave after t time. So, or you can say, let me show, let me draw it with different color here. This will be the situation. Okay, so now you can see, it means if we can see here now p point is here. Okay, so it means this particle is moving in upward direction, because these particles are vibrating like that. They are vibrating in vertical direction. So either they are moving in upward direction or downward direction. Okay, so this is one of the easiest way to get the direction of velocity of particle. After that, I'll give you one more method. I'll give you the mathematical formula which we can use to get the direction. See here, let us take one more example. Let's take here one more example. See, suppose if this is the if this is our particle, suppose this is our particle. Okay, and we have to find our direction, and wave is suppose traveling in this direction. So in that case, see, after t time, this will be the situation. Wave will be here. Okay, so now you can see this yellow color particle. This particle is moving in vertical direction. They are vibrating in vertical direction. So now this will be here. Okay, it means this particle is moving in upward direction. Here, particle is moving in upward direction right now. This is the direction. Okay, at this point of time, the direction of this particle is also upward. Okay, so let me give you one more mathematical formula to get the direction of motion of this particle. See, velocity of the particle is equal to minus of velocity of wave into slope. This is one of the formula which we can use to get the velocity of the particle as well as the direction. See here Vp, you know very well, Vp is velocity of particle. V is what? Velocity of wave. This is velocity of wave. So students, in this case, let us see, in above case, in example one, you can see wave is traveling towards positive x-axis. Okay, fine. So here direction of v is what? Direction of v is positive. Now what about the slope? Slope, see, this is our p point. Now this is our p point. So we can draw here a tangent at p point to get the slope. See, let us draw the tangent here. See, this is the tangent. So this tangent is making an angle of what? More than 90 degree with the x-axis. More than 90 degree means what? Here slope is negative. Because first of all, this is our P point. Draw a tangent at P point. Okay, and that tangent is making an angle of more than 90 degree with the x-axis. So it means sin theta will be negative. It means slope at P point is negative. Okay, so this slope is what? Negative. So what we are getting here, you can see minus plus minus. So we are getting here plus. It means we are getting here velocity of particle, direction of velocity of particle is what? Positive. Positive means what? Particle is moving in upward direction. Okay, positive means upward direction, negative means downward direction. So it means direction of motion of this particle is what? Upward direction. That's it. This is one of the way which we can use to get the direction of particle. In earlier one, we discussed here the direction of motion of the wave as well as the velocity, how to find out the velocity of the wave. Now we can use these two concepts to solve our first example, or you can say first question. See here in this question, uh, we need to find out the velocity of this particle p. You can see velocity of this particle p, and according to this question, wave is traveling in which direction? Towards positive x-axis. Okay, so if we'll talk about the velocity of the wave, see here, v is what? Velocity of wave. So v is velocity of wave. Okay, velocity of wave. So it means and direction of wave is what? Towards positive x-axis. Okay, positive. Okay, if we'll talk about velocity of the direction of of this particle p, we have to find out the direction of this particle p. So students, let's see, we can use our mathematical formula. Vp is equal to minus of v into slope. This is the formula now which we can use to get the direction of velocity of particle. So see here, if we'll talk about direction of motion of wave, so wave is traveling in positive x-axis. What about the slope at p point? So if you find out the if you want to find out the slope at p point, draw a tangent. Okay, this is a tangent. This tangent is making an angle of more than 90 degree with the positive x-axis. It means here slope is negative. So it means slope at p point is negative. So this is negative. So minus minus plus, it means we are getting here plus. It means positive means what? It is showing that particle is moving in which direction? In upward direction. Okay, so here particle is moving in upward direction. Upward direction means what? Positive y-axis. Upward means what? Positive y-axis. And how can we show the direction of positive y-axis? By using unit vector j. Plus j means what? Plus j means direction of the particle is what? In positive y-axis. So if we'll see these four options, you can see incorrect. This is if we'll talk about option B, incorrect, because here minus j. Okay, here direction is what? Minus I, that is incorrect. Here direction is what? Plus I, that is incorrect. But in option A, you can see plus j. Plus j means what? Direction of this particle is what? In positive y-axis. That is absolutely correct. So here correct answer is what? Option A. So this is all about this example. Okay, so now we can discuss our next example. You can see, so first of all, you can see on your screen, a pipe of length 85 centimeter is closed at one end. Okay, then find the number of possible natural oscillations of air column in the pipe whose frequencies lies below 1250 Hz, and the velocity of sound in air is given 340 meter per second. So what we can do here? So first of all, let me give you the idea about the closed organ pipe and open organ pipe, and after that we can use that concept here to solve this question. Okay, so let's start now. So first, let me give you just idea about the open organ pipe and closed organ pipe here. So okay, so here you can see first closed pipe. Okay, for closed pipe, suppose one end of this pipe is closed. Okay, one end of this pipe is closed. Let me draw here three diagrams. Okay, suppose from bottom this pipe is closed. Okay, and suppose the length of this tube is suppose L. The length of this tube is L, I can say. Okay, suppose length is here L. Length is L. So if we'll draw here stationary wave. Okay, displacement, you can say displacement of stationary wave. First of all, this is the displacement wave of stationary wave. Okay, stationary wave, you can see these are the nodes. Okay, nodes. Okay, and this one antinode. Okay, so at closed end, we'll get here antinode. At closed end, we'll get here node, and at open end, we'll get here antinode. Okay, so the minimum possible separation between antinode and node is what? This is the minimum possible. See, This is the minimum possible separation. Okay, so you know very well here in this from this diagram you can see this is what one complete wave. So wavelength is lambda. So for this one, I can say lambda by 4. Yeah, exactly, Kishore. Lambda by 4. So it means this length is what? Lambda by 4. So it means length of this tube is equal to lambda by 4. Okay, lambda by 4. So now here lambda is equal to 4 into L. Okay, lambda is equal to 4 into L. This is the wavelength. Now we can find out the fundamental frequency, or you can say frequency of this wave. See, frequency F is equal to V by what? V by lambda. V is what? Speed of air. So now V and lambda is what? 4L. So this is known as what? This is known as fundamental frequency. So for closed organ pipe, fundamental frequency is what? V by 4L. Okay, this is what? This is fundamental, okay, fundamental frequency. Now let's talk about the second case here. So second possible case here is what? This is our second possible case here. You can see antinode, node, antinode, and node. So this total length is what? This total length, anyone who can tell me this total length? This is lambda by 2 plus lambda by 4. So what will get here? uh, we'll get here 3 lambda by 4. So length of this tube is what now? 3 lambda by 4. So lambda is equal to 4L by 3. So now again we can find out frequency. So frequency is equal to what? That is equal to V by lambda. It means V by 4L into 3. Just put the value of lambda here. So you can see this F is what? 3 times of fundamental frequency. See, this is V by 4L. Na? V by 4L is what? That is our fundamental frequency. Na? So this one is 3 times of fundamental frequency. So this is known as third harmonic. This is what? Third harmonic. Okay, third harmonic. Now let's move on to the next case. So you can see this one is also possible here. Na? Okay, so what would be the total length? Anyone who can tell me? Total length. So see, first of all, lambda plus lambda by 4, it means 5 lambda by 4. So here length of the tube is what? 5 lambda by 4. So lambda is equal to 4L by 5. This is the value of lambda. Now we can find out the frequency in this case. So F is equals to V by lambda. So F is equal to V upon 4L by 5. Okay. So here F is equal to 5 times of V by 4L. Okay, V by 4L is what? That is our fundamental frequency. So in this case, F is equals to 5 times of F naught. Okay, so this one is what? This is 5 times of fundamental frequency. So this is what? This is our fifth harmonic. Okay, this is what? This is our fifth harmonic. Okay, this is our fifth harmonic. So students, here you can see, okay, so some of the students are asking how am I writing here lambda? Let me tell you, students, see here. First of all, if we'll talk about this is what? This is complete wave. This is one complete cycle. This is lambda. Okay, this is lambda. Okay, for half, this is what? For half, this is lambda by 2. Okay, and this, for this is half of lambda by 2. So this is lambda by 4. Okay. So this is lambda by 4. This is one complete cycle. This is lambda. That's why lambda plus lambda by 4. Okay. So this is our fifth harmonic. So you can see here, in case of closed organ pipe, we are only getting here odd multiple of this. This is what? Odd multiple of harmonic. See, third harmonic, here we are getting fifth harmonic. Similarly, we'll get here seventh harmonic, so on. Okay, so we can say that This is what? Odd multiple of harmonic. Okay, odd multiple of harmonic. Similarly we can calculate for open organ pipe. I am not going to explain that part because you can easily do it. So but let me tell you, for if we'll talk about the open organ pipe, so that is what? For open organ pipe, open organ pipe, let us discuss on next board. Here we can discuss for open organ pipe. Okay, see, suppose let's talk about the open organ pipe. So we can select here a pipe tube. Suppose this is the tube. Okay, so we'll get here anti. So here anti node, and here also anti node. So minimum possible case is what? Minimum possible separation between two anti node is what? This. Okay, and this total length is suppose L, and that is equal to what here? L by 2. So here lambda is equal to 2L. So F is equal to what? V by lambda. It means V by 2L. Okay, so in case of open organ pipe, fundamental frequency is what? V by 2L. This is what? Fundamental frequency. Now, if we'll talk about the next case. Okay, so similarly you can do the Duke of similarly you can do for next two cases. Okay, next two cases, and what you'll get here? Here you'll get F is equal to, I'm directly writing here, you can do the calculation. So here you'll get 2 times of fundamental, here you'll get 3 times of fundamental. Okay, so it means in case of open organ pipe, open organ pipe, this is what? This is what? This is for even harmonic as well as odd harmonic. Okay, this is the multiple. This is what? Here we'll get frequencies for even or odd harmonic of fundamental frequency. But in case of closed organ pipe, that is only for odd. That is only for odd multiple of harmonics. Okay, so let's talk about this question. So students, you can see here, suppose first of all, fundamental frequency for closed organ pipe is V by 4L. Okay, so speed of velocity of sound in air is 340. Okay, fine, great. For length of the tube is 85 centimeter. It means 0.85, or I can say 85 by 100. 85 by 100 meter. Put here 85 by 100. So you can see after solving, you can see 85 for 4 cancel. So I think we are getting here 100. It means here fundamental frequency is 100. Fine, 100 hertz I can say. So we know that for closed organ pipe, that is what? That is only for in closed organ pipe we'll get only odd harmonics. So it means we'll get F naught to F naught, 3 F naught, 5 F naught, 6 F naught, not 6, 7, 9 F naught, and 11 F naught. Okay, so on. So we'll get here. It means here I can say 100 hertz. Here 300 hertz. Okay, here 500 hertz. Okay, next one will be 700, then 900. Okay, 900, and after that it will be 1100. Okay, 1100 hertz, and next will be 1300. But we need to select only those frequencies that is below 1250 hertz na? So 1250 hertz, possible frequencies is what here? 1, 2, 3, 4, 5, and 6. So 6 is the answer. Okay, so here our answer is what? 6. Okay, so this is all about closed organ pipe. Okay, so now move on to the last question. So you can see on your screen, this question is based on what? This question is based on open and suppose a hollow pipe of length 0.8 meter. So suppose this is our hollow pipe. Okay, This is our hollow pipe of length 8 meter. You can see length zero point 0.8 meter, not 8 meter, zero point 0.8 meter. Okay, that is closed at one end and it's open at open end. At its open end, zero point 0.5 meter long uniform string is vibrating. Okay, suppose this is what, this is a string which is vibrating. Okay, and length of this string is what, zero point 0.5 meter. So according to this question, it vibrating and its second harmonic and its resonance with the fundamental frequency of pipe. It means fundamental frequency of pipe, or you can say suppose this is first and this is second. So fundamental frequency of first is equal to second harmonic of string. Okay, both are equal and we have to find out the, okay, so we have to find out the mass of the string. So first of all, you can see for open, this is what this is closed organ pipe. For closed organ pipe, fundamental frequency is what, V by 4L. Okay, suppose this is V1 and L1. Similarly, if we'll talk about this string, so student, let me give you just idea about the string first here. Suppose if this is the string, if this is the string, so minimum possible case here is this. Okay, here we'll get here anti-node, sorry, node, and here as well as node. Okay, so here this length is what, lambda by 2, lambda by 2. So here lambda is equal to 2L. So if we can find out frequency here, so frequency is what, V by 2L. This is our fundamental frequency for a string. Okay, great. Now what will be the next case? So see, this will be our next second situation, this one. Okay, so this is what, lambda. So here lambda is equal to L. Here lambda is equal to L. Great, good. So here frequency is what, V by lambda. So we can multiply and divide by 2. So this is 2 times of V by 2L. Okay, 2L, because here lambda is equal to L. So now I can say that this is 2 times of fundamental frequency. Okay, 2 times of fundamental frequency because V by 2L is F naught. So this is our second harmonic. This is our second harmonic. It means for a string, I can say second harmonic is 2F naught, or you can say 2 into V by 2L, but this should be V2 and L2. Okay, here L1 is given 0.8 meter, L2 is given 0.5 meter, V1, you can see V1 is what, velocity, speed of sound is given here, you can see 320 meter per second. This is what, this is 320 meter per second. Okay, and L1 is what, 0.8 and L2 is 0.5. What about V2? If we'll talk about V2, so velocity of wave on this string is what, that is given by this relation, root under T by mu. Okay, root under T by mu. Tension is given 50 Newton. Mu is what, mass per unit length. So mass of this string is suppose M, sorry, mass of this string is M, I can say, and length is L2. So put the value of T, put the value of V2, L2, V1 and L1, you'll get the value of mu from above equation, and after that mu, you know that mu is equal to mass per unit length, so M is equal to what, mu into L2. Okay, after doing the calculation, because calculation is your part, so you can do the calculation, and after doing the calculation you'll get option B. So answer of this question is 10 gram. Okay, so this is all about today's session. So I hope you got everything. So now we can end this session. So student, let's end this session. So thank you so much to all of you. See you in next session. Thank you.